away we go. All right, so here is the situation. We are going to work on lessons 9 and 10 today. There's going to be some redundant stuff in there because we've already done a different unit on functions, but we did it with regards to like the digital scene, which, I mean, functions are everywhere. So there's lots of, that's not what we want. Why did that happen this time? Any better? Beautiful. That's the first time that's ever happened. All right, so stick with me for the introduction part, even though it's a little bit redundant, as far as just the basics of functions with calls and definitions. Couldn't think of the other word. Okay, so we're jumping right into lesson 9. Go ahead and follow along. There'll be a video here in a second that we can stop everything for. So let's go like this. And okay, so we've got a situation. Does it come in as blocks for you guys? Probably. Let's see what happens when we run it. Okay, we run it, and we've got a bunch of quotes, or excuse me, a bunch of strings. All right, so we're given the list of console log statements that are the lyrics to the song. And we also have a couple of function calls for chorus, calls it twice. And here is our function chorus, or yeah, our function sing chorus. Let's see what we've got. We've got code using function describes the lyrics of the song. Run, program, see how it works, page to the sings, add code at the bottom, sing the chorus, add code to make the program sing the chorus. I mean, this is, I guess we're just supposed to call sing chorus here. This doesn't have to be difficult. Let's not overthink it. Okay, let me open up the other application that I need. Hold on a second, folks. Oh, why does this always take so long? Active Inspire. All right, so as soon as that clears out of the way, I do believe that's all we need to do is add a single function call there. Yeah, doesn't have to be difficult. So let's go on to the next one. I think we've got a couple of videos. And we've seen these before. I think the first time we did functions, and as soon as my Active Inspire loads up or gets out of the way, we will start it. Come on, such a slow program. Here we go. 3, 2, 1, load. 3, 2, 1, load. And this is getting absurd. Do I even need this? And I can't minimize it. We'll wait. Give me a second. There we go. Up. Sweet. There we go. All right. You've got to be kidding me. All right, well, we'll wait that to load in the background. All right, so go ahead and listen up. Let's watch this.
One of the most important concepts in computer science is how to define new commands, how to add your own words to a computer language. Most computer languages have only about 100 words or commands, and really the art and magic is in defining
You know what?
your
I don't
own
think
new
we need to
words.
watch this whole thing now that I think about it. We've done this. It's all define the function and call the function. Okay, we put our function definitions at the bottom. Those are the big blocks. And everything that goes inside of the block happens every time it's called. Just a quick refresher. A lot of you were able to get around actually doing it by just literally calling the turtle movements however many times you needed, and completely defeated the purpose, but that's all right. So functions, we know this. And defining calling, I think this one might be new.
In App Lab, the toolbox now has a tab called Functions. There are two blocks. This one defines a new function, and this one calls a function. Let's make a function that updates the number of likes on the screen and plays a sound. We'll call it twice, once in each on event block. Drag a define a function block out. Notice how on both of these on event blocks have the same last two commands in them. To help simplify this program, let's take these commands and turn them into a function.
Pretty sure I brought this up the first
And
time.
let's give the
Anytime
function a name like UpdateScreen. Now we can remove the repeated code from the rest of the program. Now click Run. Hey, we defined a function, but nothing happened. The reason is we forgot step 2. We need to call the function. To call a function, drag out the call a function block from the toolbox and put it in the program. Now add in the name of the function we just defined. Now that we have both defined and called our function, the code will...
Okay, so this is going to be the type of functions we create and use for a little while. Before, when it was like draw fish, draw all fish, that sort of abstracted, multi-level, repeat, random loop, that sort of thing was for much more common on the digital scene project. This is going to be a lot of grouping of repeated actions into a definition so that you don't have to have repeated lines of text. Now, as far as how much text or coding, programming, whatever, that this function saves in this particular app, I mean, it's 2 lines of code inside the function. You still have to call it both times. I mean, it's the savings on this are minimal, except for the fact that it's scalable. Means like as the app gets more complicated, gets bigger, has more features, you can include stuff in that function definition, and instead of making sure you have it in every location that you otherwise would.
Actually run, and the likes will change on the screen. Check it out. It works. Notice that if I also call the function before its definition, it still works. Defining a function simply gives a name to a block of code, but it doesn't actually run it. The definition can be anywhere in your program. This means that your code can get messy and really hard to read. So we typically put our function definitions at the end of our programs to help keep things organized. You can also see why it's important to give your function a meaningful and descriptive name. If you call it something like do stuff, it'll be unclear what the function is supposed to do,
awesome.
and it makes it hard to use in your own code. Giving a function a meaningful name makes it much easier to understand what it does. Using functions like this in your program not only makes your code easier to understand it also makes it easier to fix problems or errors. When you fix a problem inside your function, that will automatically fix that problem wherever the function is called.
All right, so continuing on to bubble 4. Okay, what do we have here? We have a program that looks like it's just a basic up-down clicker that doesn't work. Wait, does it work? It does kind of work. I would say it works. All right. On the line up to what is being declared. Okay, update screen is declared all the way at the bottom on 23, starting on line 23. It's being called on line 6, and every time the event handler happens, which that's going to be something that will be in a lot of your apps, where you're going to start by just calling the function up, some sort of update function at the beginning to make sure all of the user interface elements look correct for the user to start with, and then call it again every time something needs to be updated. That's common. And it's coming. Okay. How does the update screen function make the program easier to write to understand? Well, we know we can just keep track of all the things we want to change anytime something happens, put them in here, and then call it every time anything changes. So change the program. Okay, we want it to end at 15. Right now it ends at 10, 10 positive and 5 negative. Okay, so we want to check our end game condition is if count is greater than or equal to 15, or count is less than or equal to negative 10. That gives us our range. Okay, we've seen the conditionals recently. We also need to make the display word clicks. Okay, so instead of just 0, so our output is not just going to be count. Count is this global variable that we're using. It's the shoebox that's keeping track of how many clicks has occurred. Up button makes that shoebox get whatever used to be in the shoebox plus 1. And same thing, gets whatever it used to be minus 1. And that's what's being set here. That's that every time update screen is called, it's set there, but we don't want just the word count. We want, or excuse me, not just the value of the variable count at that time. We want to concat the word clicks at the end, probably with a space. So we can then concat. Is that all we needed? And we run. This should happen right away. Okay, so update screen. Oh, we want it both times. We want it with here also. Space CLICKS. Okay, that way when we hit run, it should say clicks also. There we go. Okay, so this is what's being updated every single time update screen is called, and this conditional is checking for our game over situation, our game over condition. Okie dokie. We're gonna fly through this. We're gonna get through the next lesson also. Not terribly difficult. All right, so lemon squeeze app. Worked earlier in the unit. Repeat blocks of code replaced by function. Look inside the event handler for lemon and lime. Replace the repeated update screen that you declare once but called twice. All right, so we have a play button click. It resets score, resets our global variables, checks for username and password, and so here, for the sake of debugging, I'm actually going to comment out this entire conditional so that I can just have a it'll go straight to the next game screen every time I click on it. The other thing you could do, actually, for the sake of debugging, and I recommend this, is go into design mode, switch to game screen, and click on make default. That way, when the game starts, it'll go straight to the game screen, and you can just eliminate the issue of checking username and password, because all the checking username and password does is decide whether or not you can get to the game screen. So if we start with that, we'll be good. Let me get rid of all the sounds because there's no reason for any of that. Lemon and lime. All right, so now we're trying to figure out which lines of code only need to be or can be contained in a update screen function. So not in play button. So we're comparing lemon and lime. Each of these have they update the score, but one updates score, the other updates live, so that's fine. They both have the same random, wait, hold on. If score, no, lemon is the only one, change in score is the only one that changes the size of the lemon. They both have the same set random location for both, and they both have the same update score. So let's go ahead and put the things they have in common. I'm going to get myself some white space to work with. And we'll get the things they have in common and put it into a function called update screen. And every place that they have the same thing we can put in there, which is these two things. Give me the whole thing. No, that's all right. Let's go like this. Well, we just cut it. There we go. And every place we call update screen will do this, which we need to put it at least back where we took it from. So there we'll call update screen. And in the lemon function, we can do the same thing. And that should do it. There we go. All right, so the order of this is given to you. It's pretty obvious. I mean, there's not much to change. Other than changing. Hey guys, settle down in the back, please. Summing up or replacing, condensing the repeated stuff into its own chunk, its own play in the playbook. So let's go to the next one, probably another informative situation. All right, update screen pattern. This is going to be ubiquitous for a while, having one function that does a bunch of things. And there is a check for understanding there for bubble 7. In your own words, describe the benefits of creating functions in your own code. Okay, why do we have functions? Don't overthink it. A thorough sentence or two should be enough. And let's go on to lesson 10. While you can type while I load this up. In fact, let's just go ahead and U4L. So yeah, you should be doing the check for understanding at the end of that lesson. Do that now. All right, lesson 10. So we have an app here that starts out with 4 different function calls. And okay, these functions are not called in the correct order. Rearrange functions. Okay. Okay. I guess we just have to make sure that they're called in the correct order. Spring, summer, autumn, winter. Okay. Yes, this isn't exactly extending your guys in the back. Quiet. While you talk. All right. So the point of this is just, it's the order of the function calls that matter, not the definitions. The definitions we'll just put at the bottom of the program once they work. They you can kind of ignore them, which is our one example of abstraction, simplifying things. So once you know how they work or that they work, it doesn't really matter. All right, is this going to block us from going to, no. Okay, the program building debug console. All right, so we just have a bunch of character sort of ASCII art. I don't know if you guys are familiar with ASCII art. It's like what graphic designers did before computers could do anything. But it's like art drawn entirely in characters in like keyboard stuff. Let's see if I can find one that is appropriate. That's not a good one. Is that going to work? Problem is they're not all appropriate. That's part of the problem. Just an example. All right, so something like this, where I don't know, it's low enough res you can't really see it, but the art, these are all like letters and characters and stuff like that. This is ASCII art. I probably could have found a Wikipedia article now that I think about it. Let's see what Wikipedia has to say. Give me a second. Yeah. Yeah. All right. So even something like the shrugging guy that you can type into chat, that's a bunch of like katana letters and stuff like that. That's ASCII art as well. Named after the ASCII character system that we talked about before. Anyway, the point here is to recreate this house or apartment, this building, and as it is shown, right now we don't have enough levels, floors, and we want, it looks like, so this is roof, we're good on roof. Floor is some windows and a level. And then lobby is that situation. So we just need to call floor. We have 1, we need to call it 3 more times. And that's as big as the debug console gets. No, I guess it gets full size. And I believe that's it for 4 floors. Again, this stuff isn't exactly life-changingly difficult. All right, we need to spell okay, just like everything Case sensitive, spelling matters. Spelling matters only in that they're spelled identically. You can spell something wrong twice, and as long as it's the same, you're good. And same rules for variables. Function names can't be one of the reserved words. Need to start with a lowercase letter, no spaces. There is some punctuation that's allowed, but not all. Just stay away from punctuation. You can have numbers in it if it doesn't start with a number. Just, I mean, this is the naming convention. Spends $1, blah, 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 blah. Yeah, I believe that's it. Get the message that it ran out of money. So we need to call Apple enough times so that we have $0. So I guess that's 5 times. Do we have loops here? No. So let's just call it twice more. Now I have $3. Hold on, are we losing 4? I guess once more also. I don't have any money left. Good. Okay, that's in our else condition. Okay, the conditional should look familiar at this point. Let us proceed. All right, we have an update screen function, but it's not called anywhere. Read the code, understand how it works. And add update screen changes the value stored in the thumbs up variable. So thumbs up is, so it changes. Okay. Add calls to update screen function to make the face and the text on the screen respond to the changes. Okay, so we have our update screen function. This is checking value for against a string and counting thumbs up. So we have our function definition. We just need to call it in the event handlers for thumbs up and thumbs down. And do we need anything else? I believe that's it. What else do we have? Button is clicked, decrease the thumbs by 1. There's good comments here, good documentation, but it's not exactly super complex. And I believe that's it for bubble 4. Wow, we are flying through this. And P code and program. Yeah, this is a lot like when we talked about text compression with the song lyric text compression tool, where if you're doing if something happens enough, it probably deserves its own library entry. You know, where it like replaced a set of text with a snowman or umbrella or something like that. That's sort of the same general thought process for whether or not something belongs or in its own function. And so declare a function once at the bottom, call it every time you need to use it. Okay, what set of code happens a bunch? Morning, slept in late, noon, lunch. So it looks like everything here is repeated, okay, between each thing. So let's go ahead and, again, I'll add some white space, just switch to text, enter a bunch, and then add a comment. If you don't add a comment at the bottom, it doesn't count it as white space. It just still ends it there. But I want to make sure I have nice and neat code. Let's just call this update screen. We don't need to reinvent it. We'll drag in our set of those, and everywhere we saw that same amount, we're going to have the function call. So we get rid of this and add our call there. Get rid of this and add our call there. This is it going to work? Beautiful. And if you did it right, it should look exactly the same as it did when you started. So that's satisfying. And that's it. Okay, so this is our first, I think probably our first introduction to scope. I think we talked about it before. Oh no, we definitely talked about it before. Okay, global versus local scope. Almost everything you do in this class is going to be global variables. It just prevents a lot of issues. That just means your var is at the top. When you declare a function, declare a variable and probably initialize it also, probably give it, the type of variable it's going to be, whether it's a number, a string, a list, whatever. And then every other time you just name the variable. Okay. And some of you will make the mistake of making a local variable when you need a global, but more often than not, it's just going to be you dragged out the wrong block, like you declared it at the top, but then dragged out another var in the middle, and that breaks it. Okay, so a typo versus choosing the wrong one, like this, having it declared at the top and then redeclaring it inside, it's not going to work. And do we have, how many more do we have? Yeah, let's go. Function scopes. Okay, the program should buy an apple every time the apple is clicked, but doesn't seem to be working. Run the program, see how it works. Okay, so we have a variable called dollars. It's set as 5. Apples is set to 0. Every time apple is clicked, rerun the function by apple. Let's look at this function. We have a set text. I'm guessing this is info. Yep. And this is results and dollars label. We're just trying to update variables. But because we're updating a variable using itself on the same line we're declaring it, it's broken. So you could look at that already and know that it's broken. But we just need to get rid of the vars inside the function. Vars only exist at the top by themselves. And does this work? Speed it up. I have negative 12 monies. Okay. We have 2 when declare. Okay, important question. When should I decide to make a function? Generally, earlier you realize you need a function, the better. Okay, when you create a function, never. You create no functions, all comments, your code. I mean, this is a little bit heavy-handed with regards to like how good you are at coding and planning and things like that. Did you write a bunch of code and then realize that it should be in its own function and you redo it like we just did? Do you create functions like as you're writing, you realize you need a function, or do you plan beforehand and decide on what your functions are going to be before you even start coding? I mean, if you get to the point where you realize you need a function as you're writing it, that's fine. I'd say that's the way most people go through things, but yeah. And bubble 9. Okay, program keeps track of tickets further to 1 pro and is already working. Code inside of it. The other 2 buttons work similarly. Rather than write repeated code, practice create an update screen, an event handler. So what do we are given 5, and we've seen this app before. I think when we were just talking about regular variables or just variables, we have 5 global variables. Dollars and tickets are set to 0, and then the prices that are supposed to correspond to the buttons. Adult button does a thing. What do we need inside of these? Well, we need the same stuff, which we need. We can just. All we need to do inside of the event handlers is update the variables. Okay, for child button tickets, still going to go up by 1. Dollars is going to go up by child price. And in senior button, same thing. Going to go up by senior price. And then we're going to have a function to clarify or to simplify. All of this code is going to get called every time you click on any button. First checking for a game over situation or sold out situation, and then updating the text of the various other things. So let's go ahead and get a function definition and condense. I didn't do it. Condense some stuff. Okay, this is going to be our update screen. And we want all of this to happen every time we click on any button. Now we can call update screen anytime after we update the variables. And there. See what happens. Is that 10? Yeah. And I believe that's it. Yeah. So this is going to be the general pattern for any of your functions. Update some variables based on what button is clicked, and then call your update screen, which is your, in general, update situation. And for the checks for understanding, there is some pseudocode. I mean, this can't be that difficult. Okay, it was code segment is run. All right, so we have I'll give you guys a chance to solve this one on your own. It's a little bit different as far as the pseudocode goes. We haven't seen these different cases for sort of Boolean declaring variables inside of a conditional, but here we go. So the key here is that we have a single variable called day of the week. It's being initialized, assigned the word Saturday. Then it's being changed to the word Monday. So this doesn't exist anymore. It's not both of them. It's just Monday once it gets to this line of code. Then it's checking if day of the week is Saturday or day of the week is Sunday, weekend. It's not, so that means weekday. The function, okay, so these are function calls. That makes more sense. Without the syntax, a little difficult. Procedure is another word for function. You may need to know that. So if day of the week is Saturday or day of the week is Sunday, run the function weekend, which just changes what is displayed. Otherwise, run the function weekday, which is this one. So the answer should be school day is what is displayed. Yeah, school day. Okay, so make sure you wrap all of that up. That's where we're going to stop the instruction for today. I feel like that's enough. And let me know if you have any questions.